Excel can be used to describe data in very many different ways, and we can only give a brief introduction here. We start with dataset D1, which has got 50 values which have been randomly selected from a normal population with a mean value of 7 and a standard deviation of 0.5. In Excel, we can use a number of functions to derive numerical statistics directly. So, to derive the mean value of our dataset D1, we can go to the function bar and we can look for a function by searching, and we can go to various categories, either most recently used functions, or if our function doesn't appear in that window, we can go to statistical functions. And for the mean of data, we want the average function. We need to highlight the data range. And the highlighted range is given by the cell references at each end of the range, separated by a colon. So we get a sample mean of 7.026 for data D1. For the sample standard deviation, we could also enter it directly by STD, remembering that the standard deviation starts something like STD and it gives us a range of possible options. We want the sample standard deviation, and it now shows that we must identify the number range, so we highlight the data again, this time giving the sample standard deviation of 0.494. Both of these values are consistent with the data having been selected from a population with a mean of 7 and a standard deviation of 0.5. Similarly, if we wanted the sample variance, we could remember that it is something to do with variance, sample variance, variance.s, and again highlight the data. And the sample variance is equal to the sample standard deviation squared. An important point to remember about the functions in Excel are that they are dynamic. So for example, with a mean value of 7.0262 for this data, if we were to change one of the data values, say to 5, this will automatically change the results of all of the functions. So I'll reset that value. An alternative way of getting numerical values is to use the data analysis tools, which appear under the data menu. The data analysis tools are an add-in which do not appear when Excel is initially loaded. And to bring them into use, it's necessary to go to File, Options, Add-ins, and then under Add-ins, Go, and then to select the Analysis Tool Pack before clicking OK, which will then install this particular toolpack. We have also added, which we use in other videos, the Solver add-in. But we cancel this for the moment because we have the data analysis add-in already available. So we can click Data Analysis. We will choose some descriptive statistics. We will input the data range again for D1. The data is in columns. I did not include a label in the first row, so I don't include that. I must identify where I want the output, and I will define the output by the top left-hand corner of where I want it to go, which is cell F15, and I must choose what statistics I want. I will choose Summary Statistics, and then click OK. And here, again, we have mean, standard deviation, and a whole lot of other data about dataset D1, including kurtosis and skewness. The difference between the data analysis values and the function values are the data analysis values are fixed. They are not dynamic, so they do not change if I change any values in D1. We can also use a range of calculation facilities available in Excel. So if we now look at dataset D2, which contains 50 responses to a questionnaire, and the responses are either given as strongly agree, agree, a neutral, disagree, or strongly disagree. And for example, we can use the function COUNTIF to count how many occurrences there are of each particular category. So again, we define the range, comma, and then we enter the criteria. And in E4, although it is now hidden, there is SA as the option of one particular answer. So if we enter E4 as our criteria for counting the occurrences of data and click enter, we find that there are now 8 occurrences of SA within our data set D2. If we now put $signs in front of the row references for the beginning and end of the data range, this will lock these references when I copy this function down to all the other response options. So now this counts the numbers of occurrences of each of these particular responses, SA, A, N, D, and SD. Also, if we wanted to calculate that into a percentage, we could use a little calculation within Excel. And the percentage then we would obtain by taking 100, and this will be multiplying by the fraction, in this first case of 8 occurrences of SA, out of the total number of occurrences here, for which we could calculate using sum. But we must put $signs in front of the row references again, because we are wanting to copy this calculation to the other rows, so that we now see that as percentages, SA occurs 16% of the time, A agree 40%, N 30%, etc. We could now use a column or bar chart to display the various frequencies by going to Insert, Column Chart, picking a basic 2D column chart. Then if we right click on this blank chart, we can select data, so we can add the required data range. We can also now edit the category labels to be the different responses. So now we get a basic chart showing the different frequencies of occurrence of the different categories SA, A, N, D, SD. This chart can now be edited to customize it to a required display. Similarly, we could do a pie chart. For example, for the percentages, we could go Insert and then a simple pie chart. Again, we can right click and select data. This time it's the percentages, and we click on Edit to select the various labels, and we have our chart. We can edit the initial chart in different ways. We can often point to a particular element and right click, which gives us various edit options, including formatting the data series, or we could add data labels. In addition, we can go to the menu, which allows us to give different design options, and we could add chart elements. So for example, we could add data labels, and we could choose to add data labels outside, and the labels that is given here are the various percentages of the different slices. We can point to these labels, and we can format the data labels, and we can change the label contents. We can include the category names. So this tells us that strongly agree is 16, agree is 40, neutral 30, disagree 10, and strongly disagree is 4. And this graph can then be further edited in many ways.